So we have a kind of an intimate setting here, but welcome to this week's seminar series. My guest today is Mehdi Bahrami from UC Merced, who has been working in cloud computing for some time now, has about 10 years of industry experience under his belt, as well as now working in the cloud lab, which I'll let you explain at UC Merced. For those of you who were here last September, we kicked off our whole seminar series this year with a cloud computing talk by Tim Chu at Stanford. I don't know if any of you heard that, but so here we are revisiting the cloud again. And Mehdi has been focusing on both security issues as well as like performance frameworks for cloud computing. And I am not a cloud computing person, so I'm not going to embarrass myself with going into more details to what you're going to present. So I'll just let you take it away, Mehdi.
Thank you for having me here. My name is Mehdi, and I'm from UC Merced, and I'm working in the cloud lab at the UC University of California, Merced. And this work is a joint work with Professor Mukher Singhal, the director of the cloud lab. And I'm going to talk about DCCSOA, which we proposed around 1 year ago, work on the cloud architecture. So basically, when we look at the software architecture and when we look at the specific in the cloud computing system, so we presented DCCSOA as a dynamic and customizable cloud architecture. And also we developed several case studies based on the proposed architecture. So I'm going to talk about that, why we need this cloud architecture and what's the advantage of this cloud architecture. And I'm going to talk about what's the challenge we have in the cloud computing and how this is also can provide opportunity for the cloud vendor, for the users to use these advantages. And also another challenge in the cloud computing is the data security and data privacy. And so we will focus on these two parts, and we will in this talk we will talk and we will introduce our work. The outline of this talk: we have an introduction, we have a cloud computing issues, we will talk about the DCCSOA. Introduction is based on service-oriented architecture or SOA based dynamic cloud computing, and also we present DPM as which we call them a lightweight data privacy method in the cloud computing. And we will review some case studies which we implemented on the DCCSOA, and we consider the DPM on the DCCSOA. So basically we use the DCCSOA as a platform, and then we consider our proposed data privacy method on the DCCSOA. And also several applications such as mobile cloud computing, healthcare systems, and Internet of the Things or IoT devices, how can be implemented on the DCCSOA. And finally, I will wrap it up by conclusion section. So let's see cloud computing features. So first of all, today, as we know, we use the cloud computing features such as share hardware on the virtual machines. And also we use the self-provision, so we don't need to ask someone to provide new infrastructure. Or even, for example, today we want to add the size of the storage. For email, you just increase the size. So you don't need to ask administrator, I need to add the capacity. So you do your own self. And also we use the cloud computing for as elastic capacity. For example, today we have a startup company, start by 10 clients, and we use some storage and CPU. And then when our customers increase, so we increase the resources. So basically, based on the resource, how much we need, we increase, and sometimes we can decrease this size. And also we can eliminate the operational expenses, which means we don't need to ask someone to work on the administrator and ask, so today we need to this capacity, tomorrow need less capacity and, for example, add more storage, add more CPU. So we don't need to ask anyone because all of them managed by kind of API, so application programming interface. So basically, we connect as a DLL or some web service, and we can configure our own service. And then we can pay per use basis. So when we use the cloud computing, you don't have to pay additional fee. For example, you buy expensive servers and use the pay a lot of for bill, and then so the pay per use model introduced. So we have a different rate, sometimes based on point, sometimes based on the current rate, and we can pay how much we use the system. So this is the kind of definition of the cloud computing. And when we look at the cloud computing based on national standardization or NIST, provide some issues in the cloud computing niche. So in the cloud computing environment, one of the issues is the lack of interoperability standards. And as we know, today we have different cloud computing environments, and different platforms provide own services. And each cloud vendor use their own service. They provide their own API. They provide their own service. So it's a kind of a specific each cloud vendor provide the service. So when we introduce each cloud vendor own service, then we remove the standardization between the cloud vendor services. So as we expected, in this talk, we categorize two parts in this evaluation. And as you can see, we focus on the one part as interoperability standard. Second one is bringing back in-house may be difficult because when you transfer your data to the cloud environment, sometimes you need to configure whole the system with the new infrastructure, which we call them virtual machines. And then based on these virtual machines, we can develop and deploy our system, and then we can run our application on the cloud environment. But some customers say it could be make it difficult when we want to decide return back the data and application to the our own IT infrastructure. Some sensitive data sometimes they need, for example, cloud vendor receive several attack scenario and then wants to bring back the data. So this is the second part. And the third part is hard to integrate with in-house IT. So as we know, each IT department provide their own service. They provide their own cloud, maybe use the cloud, we call them private cloud, or even they can use the traditional systems. So most of the customer, they say we have a maybe problem about the hard to integrate with in-house IT. So suppose you have one part of data and application on the server side, and you have another part on the in-house IT department. So you want to integrate this data and applications between the cloud environment and in-house IT department. And it could be make a problem. So the first of the part of the talk, I will focus on these items, which our cloud architecture will kind of emphasize on these issues and alleviate these issues. And the second, and also we will consider not enough ability to customize. And so we will introduce how our architecture can provide customization in the cloud computing systems. For example, if Microsoft or Google or other cloud vendor or even the private cloud computing system, they want to customize their services for a group of the people, for a group of the customer. So how they can do it. So this is the first part of the talk. And the second part of the talk, I will focus on the another issues in the cloud computing, which is security. And most of the people consider as the main issues in the cloud computing because we use the internet base and also is a public network access. So what we want to do, as we can see here, we need interoperability. We need kind of integrate the system between in-house IT department and in cloud environment, and also we want to customize the system. So we provide this architecture. This architecture based on service-oriented architecture or SOA. So first, SOA introduced for the integration between different services. For example, traditional systems, even for military systems, because we have a specific applications. So kind of we want to have an individual service, and then we want to consider a layer on the top of this service and provide integration. So we use the SOA. So why we use SOA as a main idea in our architecture? Because we want to run our architecture on the top of heterogeneous cloud computing systems. It means we want to have a cloud of architecture which can be deployable on the top of any kind of cloud systems. And it's under the kind of on the back end, which we call them here, we explain how it works. We want to have a heterogeneous cloud systems. So the heterogeneous cloud systems provide different architecture, provide different and heterogeneous services. So basically each cloud vendor, they can provide their own service, a specific, and they don't need to modify their own system. So why we use the SOA? Because we can remove this problem. It means modifications. So if we provide the architecture to users, for example, to one cloud vendor, private cloud vendor, or public cloud vendor, such as Google or Microsoft, and they want to modify the system, and if it's required modification, a lot of modification on their system, so the architecture cannot be deployed because it's not cost effective, right? So we use the SOA as a main architecture. In the SOA, we have a bunch of services, and they can interact with each other. And also, we consider first part is a cloud vendor dashboard. So the cloud vendor dashboard provides connection between the users and the services. So the cloud vendor dashboard included two parts. One part is for the users who wants to use the system, and another part is a cloud client dashboard for users who wants to interact with the cloud vendor services. So basically this part only the cloud vendor can access. And second part is the cloud governing services, which compose several services which we need. For example, we call them template management services. We in our system, everything provided as a template. It means we use the template to provide customized services. And then we have, for example, cloud provisioning services. This is the traditional cloud services. Cloud ecosystems, management services, QoS, monitoring and metering, billing services, and cloud brokers. And another part is a component is a cloud value-added services. For example, if we consider the cloud computing system, we divide it to several parts. One part is infrastructure as a service, or platform as a service, or software as a service. So basically, all traditional cloud computing services located at this level, at this component. So any kind of heterogeneous cloud computing system provide different unique services at this level. So each unique services will be different at this level. And then the important and key component on our architecture is a dynamic template service layer. And we call them DTSL. So the DTSL divided two parts, FTAS and MTAS. If I focus on this part, we have dynamic template layer, which divided to the front end of the template as a service and back end as a template as a service. The back end interact with heterogeneous cloud services, and the front end template as a service located on the top of heterogeneous services and provide standard services. So the back end bind the service to the particular cloud vendor services. For example, if we have one API, one cloud vendor such as Microsoft or Google provide a specific API, we can connect the back end to these particular services. And then at the front end as a service or FTAS, we can provide uniform service. So the uniform service, any kind of cloud vendor, any kind of service cloud users, they can access to the FTAs. For example, so we have a FTAS, and FTAS can be accessible by cloud client dashboard. So let's see how it works. If we consider a two-layer, the front end and the back end. So this is the DTSL. So the front end provides the template to different group of users. And also we have a cloud vendor. The cloud vendor can access to the both front end and the back end. And at the back end provide the traditional cloud value added services. So we have an infrastructure, platform, software, or even any things as a services, which we call them store as a services. It means currently the cloud vendor, they try to provide any services. Do you have a question? Yeah. No, that's fine.
So the backend, I understand that the backend connects to the underlying cloud API, but what is the front end and what does the cloud vendor have to do with the front end?
That's a good question. So the front end try to provide the customized service and uniform services. Next slide, I'm going to show you how the front end at the different cloud vendor can be provide the uniform services. So it means I can provide the standard services. So when we have, for example, front end as a service, one service at this layer, different type of cloud vendor, they can provide the same service with uniform or standardization. I will show you the next slide how it works. Do you have any more questions? Oh yeah. So the cloud vendor provide the front end and the back end template. So everything we consider as a template. And then each template can connect to the specific particular services. And I describe about the store as a services. Currently, we face on different things, move everything to the cloud environments, as you know. I don't know, if you search what we have as a service, you can find everything. Even you can find, for example, I don't know, I search about that is a love as a service. It's a kind of message passing on the cloud computing environment, and you can send message and call them love as a service. So even you can find car as a service. Everything you can find transfer from the traditional system to the cloud environment, and they call them different type of service as a service. So this is make a problem. This is good because we transfer everything from the traditional systems to the cloud environment. But on another part, when we consider different type of service, it means one cloud vendor provide a kind of particular service which cannot accessible to, through every cloud vendor. So for example, if you use one service in one cloud vendor, in another cloud vendor, you cannot access to this service, right? Because it's a specific provide one cloud vendor or a group of cloud vendors. So how it works regarding that questions. So for example, if we have two infrastructure, for example, one infrastructure number one and infrastructure number two, it means the cloud vendor one provide the infrastructure as a service number one. For example, Google provide one cloud vendor service as an infrastructure in this layer, and another cloud vendor provide another service. So they provide two different services, and they have a unique services. So the vendor one can define the back end as a service. So this is the template. So we'll be offer the template. So backend template as a service, BTAS one, and the vendor two will be provide BTAS two. So is a interact with particular cloud vendor services. And at the front end, both vendor vendor number one will be provide the FTAS, and vendor number two will be provide the FTAS. So the back end can bind, interact with particular cloud vendor infrastructure. But at the front end, we have a uniform service. So this is the template. So when we have a uniform service, this end user or any kind of user, maybe it can be developer or it can be end user, can access to this front end as a service or FTAS and can use the standard services. Yes.
So who provides the front end, the FTAS? Who maintains that?
That's a good question. So the BTAS and FTAS provided by the cloud vendor.
So then in that diagram, actually, there's two FTAS, one provided by each provided by
Yeah,
each one.
in the real world, yes. But when we want to, as a customer, we want to look at the cloud vendor, we can see the FTAS. So for example, if they provide one template, so I'm a customer, connect to the cloud vendor and access to the cloud vendor service, and I can see this template. And I can ask, do you have this template? I can access to this template. So in another vendor, again, I can access to the same template, but it's required that cloud vendor provide this FTAS.
Right. So as a cloud vendor, if I'm in control of both the FTAS
Exactly.
and the BTAS, then why would I create a BTAS in the first place? Why would I not directly bind my infrastructure to the FTAS? Because as a cloud vendor, I control both.
Okay, that's a good question. So if I want to provide the BTAS, I need to provide it for the customer, make a standard service between different cloud vendors. So one part, I'm looking as a cloud vendor, I'm looking to provide the same uniform service. So one part, I want to provide uniform service. So the uniform service can be defined here. But if I want to use this uniform service, I don't want to modify my own specific cloud services, right? So I don't want a lot of modification on my system. I don't want to change a lot of things on my cloud infrastructure. So I'm going to start working on the back end. So the back end layer, kind of we provide both, we have one template. So this template at the back end binds and interacts with particular services. So I don't need to modify infrastructure at service number 2 or even for the cloud vendor number 1. I don't need to move or transfer everything I need. I don't need to touch anything in that layer or services. I just define backend to make a connection between IaaS and the FTAS.
Thanks. I guess then my question is, what do you envision as things that will change a lot in the BTAS? Because that's the case that you're making, right? That you don't want to change the back end. You would rather change the BTAS, so you're putting an abstraction layer in between. So what do you think? Why would the BTAS keep changing? I mean, what are some?
So we don't want to change anything at the back end. The back end, only thing we are looking, we want to make a connection, provide connection between our infrastructure and standard services. But why we need maybe I can add this question, why we need backend, right? How can I have the template without backend? How can I create this one? So if you look at the front end should be uniform. So we don't have any problem about uniform. But if we want to provide the uniform template, we want to make a connection. So basically, if we look at, for example, the compiler, so you want to run your application on the cell phone, you want to run your application on the, for example, desktop, and so we kind of create, for example, the backend for run the application, and we call them virtual machine, right? So this is the kind of virtual machine is the front end in this is this way. At the back end, when we want to, for example, create the infrastructure number 2, so the infrastructure number 2 is require particular configuration. And if I want to move this infrastructure number 2 to the front end without this back end, is required, for example, if I modify this infrastructure number 2, I need different BTAS, right? But if I remove the BTAS, I cannot make a connection between infrastructure number 2 and the FTAS. Why? Because the end user can access to this one will be same as this one. And so again, we have a different heterogeneous services in the cloud environment. So our purpose is we want to provide uniform services, but we don't want to change this one. If I remove this one, I have to change this one. So I want to keep this one, and also on the front end, I want to change and modify the service. Yes.
So you're just saying this backend BTAS2 is just a mapping, basically.
Yes.
So that's
yes.
It. Okay. So the arrows are just information or API calls or whatever, and you're just mapping the native IaaS2 API calls to some neutral API call.
Yes, exactly. But so we are interested in when we want to provide like a different infrastructure. So the BTAS can be modified for different type of infrastructure, or even platform as a service. Here it can be software as a service. Anything can be here. So we have a particular backend related to this part, and then we have the front end uniform and standard services, and can be customized. Yes.
And you say standard. You guys invented the front end API, or you're using some industry standard, or what is that?
So the standard. So what we define the standard services? The standard services we want to provide give opportunity to different cloud vendor. They have a heterogeneous cloud vendor, infrastructure or platform software, so they can provide the same feature. Yeah.
But when you say standard, you don't mean like ISO standard.
Oh, no. So we not follow any standardization for ourselves, but we provide the opportunity for the cloud vendor to define services can be used between different cloud vendors. Any question? All right. For example, if we look at this is one snapshot of the dynamic BTAS. So suppose we have a software as a service platform and infrastructure. We want to define different template. This is template number 1. The template number 1 covered just only SAS. But if you look at the template number 2, covered 3 layers. It means I can customize the services based on different type of template, and I can offer template to different group of users. So what I can use this kind of template, what's the advantage? One of the problem in the current cloud computing system is the customization. So if we want to customize the services, for example, 2-3 APIs, and we want to consider one API to the users, currently we don't have this opportunity. We have to provide different API to different group of users. And users, they need to modify their own systems based on what we provide. But if we provide, for example, the template number 2, they can access at the same time to different type of services. Can be integrated of the services. Why? Because if we have, for example, different type of services at the back end, but one front end as a service, so at the front end can integrate several services. And also we we compare our architecture with other studies, and we consider one of the method evaluating a service-oriented architecture, which is a technical report uh, developed by SCI at CMU. So we consider, for example, customization and standardization with minimal modification to architecture and services. So how we can customize the services and the capability of the support interoperability. So between different services, we want to make a connection and we want to have this relation between heterogeneous services. And also we are interested in to support different type of services and provide the uniform services. So one of the well-known studies called CCOA is this reference, and we consider like a DCCSOA against this CCSOA, and also we provide a framework to evaluate based on current different study, and so this is the one evaluation. For example, we have different parameters in this SOA evaluating platform. One of them, for example, consider target platform, and we consider like a synchronous versus asynchronous services and granularity services. For example, in the target platform, we have several questions, several parameters, and we consider our architecture can pass this credibility or not. If they can pass, for example, RSOP, like a message automatically transferred to and from object by the platform or not. So we can consider based on these parameters, and we can evaluate two different architectures, service-oriented architecture. One study is we consider our architecture against others SOA-based architecture. Another one, in the cloud computing environment, we have several tools and frameworks to provide a standardization between different cloud vendors. And also we have research-based articles, and also we have different object-oriented tools to provide uniform and standardization between different cloud vendors. In our paper, we provide a framework to evaluate based on different services, different architecture, different tools, and we consider you may take a look to the paper, and if you search on the internet, this is where you will see the paper. So I'm not presenting here that framework, but this is only the comparison between DCCSOA and CCOA. That framework is more, we consider different tools, different services, different architecture, and different object-oriented tools. So basically, we evaluate our architecture to other architecture and services. And based on this evaluation, our architecture will provide a better performance. And one of the evaluation is we consider how the system can be useful for the provide the as a software engineering method, provide less modification, does not require heavy also computation, because when run this kind of architecture on the top of heterogeneous cloud services sometimes provide overheads. And when we have overheads, extra overheads, and it should be cost effective. If it's require heavy computation, so sometimes it's not required to use the service. So for this problem, we want to consider our architecture when we want to run some application on the architecture. One of the kind of problem in the cloud computing is a data privacy issue in the cloud computing. Because when you consider like a mobile operating system, collect all photo data, and you use the cloud computing environments, and also you outsource data to the clouds, sometimes it's semi-trusted. So sometimes you use the public cloud computing system. So you have to outsource your data, sometimes without encryptions. So one of the solution for considering security in the cloud computing systems, we can encrypt everything and then submit to the cloud vendors or storage, or we can have a computation on the cloud environment. And also, as a HIPAA introduced, we have several issues. You cannot, for example, simply just submit your data to the third party. And we have some regulation and policy. We need to take care about that. So we can use the encryption, but the encryption on the client side sometimes is expensive and is not cost effective. You want to, for example, on the mobile cell phone, you want to take a picture and you want to storage on the cloud, and everything you want to encrypt and submit to the cloud because it's take CPU and need energy. So probably your battery will be finished rather than use 1 day average, will be finished in 1 hour. Yes.
So, since you're talking about privacy and you suggested encryption on the client side as a solution, then so by privacy issues, are you purely referring to like the security involved in transmitting the data to the cloud? So in the part where the data gets sent from the device to the cloud, that's what you're referring to.
Yeah.
Okay, so encryption in transit is not sufficient, so that's why you're saying that encryption at rest is also needed.
Yeah. So basically, we want to say the best solution, one of the best solution we can use is encryption. So encrypt everything and submit and outsource to the cloud environment, right? But basically, encryption on everything is not possible. For example, you use mobile devices. You want to take a picture. You want to submit to the cloud, right? You want to encrypt everything. And see, if you want to encrypt single file and submit to the cloud and upload to the cloud, and when you want to again download from the cloud, it's expensive. And also, it's one study. Another study is most people say, for example, you use the IoT sensors. It's a small IC and use, for example, sense, I don't know, sometimes light, sometimes the temperature, and submit to the cloud. If you want to encrypt on these small, tiny computing machines, it's not possible, right? So we are interested in when we want to submit anything to the cloud. Sometimes we use own cloud computing. We call them private cloud. So when we use our own cloud computing system, private cloud, sometimes we call them the trust cloud because we don't have any problem. Sometimes we use the public, every cloud vendor provide the service, a storage service, or we can submit the data and also we can process the data on the cloud. So we call them semi-trusted. So in that semi-trusted environment, we need to take care. So for example, HIPAA Act kind of regulate, and you cannot submit, for example, for healthcare systems, you can submit just original file to the cloud. So you have to encrypt the data, or you have to kind of protect the data, user data, and then submit to the cloud. So we introduce a DPM, which start by work on like a kind of, if we think about that, we have one picture and you want to, based on the mobile devices, you want to split the different files, and then you want to submit to the cloud vendors. Sometimes you want to use one cloud vendor, sometimes you can use multiple cloud vendors, but the method can be deployable for the different type of cloud vendors, kind of split the data And if one cloud vendor access to one part of file, it still cannot retrieve the original file because it still needs another part of the data to retrieve the original file. So in this study, I'm going to introduce you why we need the data privacy in the cloud computing environment, and we want to use this DPM under our proposed cloud architecture, which we call them DCCSOA. So we have a different encryption methods on the JPEG file as a case study. For example, if we have take a picture, we have like a binary, and then so we consider the JPEG encoder, which the JPEG encoder shows the resolution, and create canvas based on the X and Y and color, and then finally we have the picture. So some study provide I can use the encryption. For example, encrypt the X or a Y, or sometimes they encrypt the color, and the final we have this kind of image. And when we want to retrieve the data, you can use the decryption and, for example, decrypt the X or Y or color. So this is the original file. So one part we can use the JPEG encoder function. So the JPEG encoder function retrieve the file from this binary file. Sometimes we can have it encrypt the data to hold the file and encrypt this binary file. So we consider both status. One part I will consider the encrypt the whole binary file, and second part we can consider the JPEG encoder and use the JPEG encoder function and encrypt, for example, X or Y or color to encrypt the data in the picture. And if you look at the JPEG file, it's composed of the several tags, and we consider the, for example, when you see open in the binary format, you can see the start of image, start by this byte, or start of frame. So we consider different frames. This is difficult case of when we want to consider data security and data privacy in the cloud computing system. Why? Because the JPEG format is a kind of 8x8 frame. If we split the one part of file, and when we want to retrieve one part of this file, so still, for example, you have an encrypt on original file. But if the attacker can retrieve one part 8x8 bytes file, can retrieve part of image. So we want to take care about that all bytes can be encrypted. So I will explain more next slides. For example, if we have a JPEG, so the JPEG file is divided to several minimum coded units, or we call them MCU. So each MCU retrieves part of image. For example, if I encrypt the whole image, but I did not consider like one MCU, still I can retrieve this part of image. So it's but if you have a binary file, if you encrypt all part except one part, you cannot run the application, right? Because it's you need all binary files consequently retrieve and read the data and then can run. But the JPEG format, if you miss one part, still one part can retrieve and the part of image can be accessible, as we can see here. So we consider a scramble function based on the chaos system. We provide a pseudo-random number generation. And when we consider like a pseudo-random numbers, why we use this permutation? Because if we have a long sequence of the bytes and we permutate the data, and we have enough lengths, for example, more than 130 the size. And when you want to retrieve, you need to run brute force search. It means you try everything to find the original file. So it means it's require the case 2 power n, and it's require n factorial. So this is 2 power n. So it means if we increase the size of file more than 130, basically the regular computer machine requires several hundred years to retrieve the file. So we consider the JPEG file as a case study. For example, we have a file. In the JPEG file, one part is a metadata, can retrieve the picture size, resolution, and other stuff, and also the rest of file we have. So we consider we split the file to different parts, and when we split the file to different parts, we consider pattern. So the pattern is as a key. So the pattern say, for example, the first part goes to first file. The second part goes to the second file. But the third part goes to the first file. So we can consider the source file, we can consider the pattern, and then we have a splitted file. So for example, we have 3 files. If we consider this pattern say if we have this is the original file. So black 1 to black 9. So we have a black 1, so we have a pattern. Is the black 1 goes to the file number 1, black 2 goes to the second file. Again, so we can consider B1, B2, B3, B4. So it's a kind of pattern. Tell me, how can I split the file to different files? Okay. And then we can consider finally the original file split to different parts. When we split the file, we use a function. We call them the chaos behavior of this like a pseudo-random generation. Provide different rate of numbers, and then we consider different pseudo-random numbers. And if we look at the series of the numbers here, we define different rates. So each time when we want to run on the cloud computing environments, we provide different parameters, input, and then provide different rates. If we consider different rates, then PRP provide different. Then DPM provides different rates for the modification on the original file. For example, we have a one file provide one input. We call them mu by these numbers. If we enter these numbers, provide this modification. It means the first pointer goes, for example, the first chunk of the file separated and add to another location, move to another location. This is, for example, the 35 and 36. This is the difference between 35 and 36 chunk. This was the size modification and move to 200. So, for example, if we understand we have a different MCU, so we kind of, based on this rate, we permutate the picture. But we not consider the MCU, we consider the binary file. So when we consider binary file, so each time we have a permutate the file based on different rates. And when we have a different rates, this is the performance of the final running the method. And as we can see, this is the encryption on the JPEG file. If you remember, we say use the resolution, for example, encrypt the resolution, color, or something like that. So this is so related to the picture. So if we provide some type of picture, the performance, sometimes we have a peak here. And also we consider AES encryption method. And also we consider our method kind of flat, but we consider, as we can see here, kind of zoom this part, and also for the decryption. We have also considered perfect accuracy of the DPM, how the level of the security of the method. But we assume that we have a different numbers based on this the DPM and different security methods, and it's required to be the length of the file should be enough, more than, for example, more than 130. That make a problem for attacker to retrieve the file. This is assumption. So if we do not pass this assumption, basically we cannot use the method because it will be not secure. And also we consider different attack scenarios. You can find it in the paper. One case study we consider for healthcare system, we use the FTAS and BTAS, and we run our DPM on the BTAS. So kind of BTA, assume that one cloud vendor provide DCCSOA and wants to use the DPM on the back end. But the front end, any kind of healthcare system, they can access to the system by uniform services. And we consider artificial large medical data sets, which compose several medical data records. And this is the performance. For example, we run DPM and AES on the back end of the DCCSOA, and this is the performance of the red curve is a DPM, and the blue one is the encryption based on AES, which is a standard encryption method. And this is for we compare between different input size with a small size between 7 to 300 bits. And also another case study we consider cloud PDP, which will be presented in February. Basically, is use the database on the cloud and also consider the DPM at the back end of the cloud, and we consider the KeyDB, which collect this different rate of the DPM. So basically, the DPM provide a pseudo-random number array, and MapDB consider each file and connect each file to a pseudo-random number sets. And finally, we have a SecureDB. If, for example, attacker can access to the SecureDB, still cannot retrieve the original file. So we consider TPCH, which is a standard database for the benchmark with a scale 1 GB, and we consider ADO.NET on Windows Azure. And this is the performance shows AES and DPM. We compare both of them, and also we consider data binding latency between AES DPM when we run on the back end of the DCCSOA. So as the purpose of this study, all of them is a case study. So we consider how the performance can be radically change the performance or add more overhead or not. So that's a reason, as we can see, the AES and DPM, and also our DPM provide the better performance. And this is response time difference between AES and DPM. As we can see, for example, when we have a number of requested field in the query, 63,000 request field from the database, we can save around 3,000 milliseconds. So for the database management system, is so kind of performance is important. And also we consider DPM on the IoT devices, how it can be run, and also we use the historical power consumption, how the energy can be used on the IoT is a kind of sensor, and how the DPM can save the energy. And in summary, I can say we use the DCCSOA and its advantage for the cloud vendors, and also we consider data privacy method or DPM on the DCCSOA, and we consider different case scenario, and also we consider different attack scenario against the DPM you can find on the paper, and also we evaluate the system based on healthcare system, database management system, and IoT devices. And so all in all, we are interested in to see how this DCCSOA behavior on the different type of services and how it can provide the advantages and also standardization and less modification. And our future work, we are working on the TPM and actually DPM on the GPU, and also we interested to run database query, kind of scramble or encrypted data on the database, so we don't need to kind of decrypt the data and then run the application. So basically, we run the encrypted data on the encrypted database. And this is our references, and feel free to visit our website. All papers available on our website. I would be happy to take your question if you have.
I have a question,
Go
actually.
ahead.
So can you just speak a little bit to how you tried DPM and IoT devices?
DPM on IoT devices, we considered, for example, the front end provide a uniform access to the IoT sensor. So IoT sensor connect to the IoT sensor connect to the front end, and the front end provide one specific particular services, and the DPM run on the IoT devices. So DPM run IoT devices on the IoT, kind of encrypt the data and submit to the front end. So the front end then is a uniform. At the back end, we have a different kind of cloud vendor. Any kind of cloud vendor can be, but on the front end, we have the same feature, same uniform services that can be provided to different type of IoT sensors.
Okay, well, we have some refreshments outside, so if you can stick around, we'll maybe have some one-on-one conversations.
Thank you.
outside.
Thank you for having me.
And I have a gift, memento.
Great.
Thank you for coming to give us a talk.
Thank you.
Going back.
Thank you. Thank you. Thank you for this.